Clear to land, simply just push forward, set a rate of descent, and touchdown.
That was spectacular. Thank you, buddy. Thank you, the flight test team. These guys and gals knock it out of the park each and every day, and I'm so incredibly grateful. I'm also thrilled that each and every one of you is here. This is a fantastic day for Joby, and it would not be nearly so special without each and every one of you. Really, really grateful. So this last year, we flew more than 10,000 miles with that aircraft, and bringing our total to nearly 30,000 miles that we put on the fleet. As Buddy talked about, we've made this routine, and this is a really fantastic accomplishment. But what we're here to celebrate today is the rollout of our first aircraft off our pilot manufacturing line here in Marina. And specifically, we've really excited to announce today that we have received from the FAA our special certificate of airworthiness for that aircraft. So, and so I would love to just celebrate a little bit and play a video that showcases the incredible work from the Joby team over the past months building that aircraft. And I think as special as this aircraft is, and the part that is the most inspiring for me and the part that just gives me so much joy each and every day is the Joby team. And to each and every one of you, both the folks here in person and the folks back at our other offices and around the world, working so hard to bring this new mode of transportation to life. Thank you so much. So grateful to you.
I see something that I didn't think was possible 3 years ago.
I see something that's a really beautiful system that's truly unique.
Something that's never been done before.
I see the beauty of what human innovation can create.
I see people who are not willing to take no for an answer.
I see thousands and thousands of hours of collective hard work.
An immense amount of pride.
At Joby, we see a decades-long dream realized. It's a vision of electric flight opening up the skies to make it easier to get wherever you want to go. Introducing the world's first eVTOL built on a production line. And our next big step toward making fast and quiet flight part of everyday life.
I see people having more time with their families rather than sitting in traffic.
I see the future in which you can see a plane and not hear it.
I see this as a paradigm shift.
A huge leap forward.
Woohoo! Okay, so now in order to help welcome and roll out this plane, I would like to welcome President and CEO of Toyota North America, Ted Ogawa, on stage with me. Ted is joining us today, or announced today. Ted will be joining us on our board of directors. This is a huge moment. Woo! Ted has been Toyota for 39 years. Last year, Toyota North America produced 1.7 million vehicles, did more than $100 billion in revenue, employs more than 40,000 employees, and it is just such an incredible honor to have Ted joining our board and joining the Joby team, bringing this new age of mobility. So with that, Ted, I'd love for you to say a few words. Thank you.
All right. Wow. Wow, thank you, Joven.
Hello, Team Joby, and hello, everyone. And I'd like to thank you again, Joby, and to inviting me here today. It's a pleasure and an honor to be a part of this celebration. The great collaboration between Joby and Toyota, which started back in 2019, was born out of a shared vision of creating mobility for all and finding better ways to move people, not just on the open road, but also in the skies, breaking barriers and making what seemed impossible possible. We share Joby's vision to save billions of minutes in commuting times, and for anyone who has driven on highways during rush hours around the country, that alone seems like an impossible task. But the fusion of Toyota's rich legacy in manufacturing, production, and engineering, coupled with Joby's cutting-edge technology, passion, and trailblazing spirit, was the perfect match to help redefine the concept of commuting. We see our investment in Joby as an investment in the future. Our partnership is not just at the board level and monetary, it's also at the ground level. Our engineers are working side by side with the Joby team. We are providing our expertise to support the production and assembly of the company's aircraft. And by applying our Toyota production system, we aim to help Joby meet high standards of quality, reliability, safety, and cost effectiveness. We also recently signed an agreement to supply key powertrain and actuation components for the production of their aircraft. Our goal is to provide the help they need, whether that's parts, people, or processes, so Joby can achieve the mass production of their electric vertical takeoff and landing vehicle. Ooh. Thank you. So we are so excited about the future, a future where flight becomes a common mode of transportation, making lives easier, commuters shorter, and the world a smaller world. Please, Joby and Toyota will help redefine the future of mobility and make the impossible possible. Thank you.
Stay with me for one moment. Thank you so much. So without this Toyota partnership, it would not have been possible to... Without this Toyota partnership, it would not have been possible to bring this aircraft, our first production aircraft, out. And so it is with my deepest gratitude, and I'd like to ask all of you to celebrate with me our incredible partnership with Toyota, and I would like to specifically thank each and every one of the Toyota team members that's here with us today, and the Toyota team members that have been working so hard back at home in Japan. We could not have done this without you, and we are so excited about the future ahead together. So thank you so much. So to help talk you through, so this aircraft is just one of the pieces that goes into delivering the product that we're here to build, which is an air taxi service. And so to help talk to you about what that product is and about that vision, I'd like to welcome Eric Allison, our head of product, to the stage.
Thank you, Joe Ben. All right, so I'm Eric Allison. I lead product here at Joby. It's a great privilege to do that and to be able to talk to all of you today about what it is that we're doing and why we are here celebrating this amazing machine that you just saw for the very first time. So the problem that we're trying to solve is congestion, it's traffic, it's making our lives better in the way we move on a daily basis. And I think it's really important to remember that. We always need to start at the beginning. What are we doing? Why are we here? Why are we creating this magic technology? But how is this actually going to work? So this is kind of the basic way that our service is going to work on a daily basis for people. So pretend that you're in Manhattan, you're in lower Manhattan, and that you want to get to the JFK airport. There's probably a few other people that want to get there at the same time as you. So through our partnership with Uber, one of our key partners in the demand side, you'll be able to select the Joby service in an app on demand to get to the airport. And then through the magic of the technology that we're building, the software in the backside, we'll bring together multiple of those requests on an on-demand basis, filling one of the Joby aircraft and getting you right to the airport in maybe 7 minutes instead of the hour that it typically takes, if you're lucky, on the ground if you're going to JFK. And then you'll be able to go right to your gate with our partner Delta, I'm sure you're flying, because what better way to get to the airport than doing this and avoiding that congestion that we waste our time in life so much on. In fact, I think it's something like 360 million hours per year are wasted in San Francisco alone in people sitting in traffic. 4.6 billion hours wasted in the top 15 cities in the US. It's crazy how much time that we can save people with this technology. So, but what is the actual characteristics of the type of aircraft that can actually make this type of a magic service work on a regular basis? To answer that question, we look at data. The time that I spent at Uber, I really got to understand and know what it's like to be traveling, what data means in terms of how people are moving on a daily basis. In New York alone, there's something like 29 million trips per day that start or end in the city of New York. Of those 29 million trips, 99.4% are less than 50 miles. This is the way, the way that we are able to save people time when we serve these types of trips. And it's not just true for New York. In Los Angeles, the distribution of trips is a little bit different, but it's the same characteristic that holds. The vast majority of these trips are less than 50 miles. That's the mission that we have to design this aircraft to actually serve. But we know it's not just about how do you serve these general sets of trips. What we need to do is we actually need to be able to design networks that actually can serve people in a way that they can use this type of a service in their daily lives. So we've developed tools to do that. Using that same data, that same understanding of movement in these major cities, these focus markets that we have, we can actually build networks of skyports and understand exactly where to place these skyports so that we can serve the most people with the minimum amount of effort, driving the economics of this whole service to be positive. So let's just take this as an example. Here's the starting point of Manhattan. A lot of people live there. Where do we think they want to go? So our tool can actually tell us where the demand is for people to go if they're starting in Manhattan. So here we see the top destination is JFK Airport. No surprise, I guess, in some ways. But we can go further from that. We can actually continue to build out these networks and understand where's the next best place to place a node. In this case, it's selecting Staten Island. And so on and so forth. We can build out these networks, developing this understanding of how do we actually make this service real. So this is existing demand that we're looking at. This is from data where people are actually moving today. But we know that's not all there is. There's actually many interesting places in that less than 1% of trips on a daily basis that start or end in Manhattan where people would like to be going, but it's hard because traffic and congestion is just so bad. We call that latent demand. So this new mobility option that we're building will actually enable people to do these types of trips out to, say, 100 miles that they just can't do today. And that's really exciting because we're making new options. We're opening up a new market for how people can move. So what are the characteristics of the actual aircraft, of the machine, that can make this possible? What do we care about when we think about designing this beautiful aircraft? Well, it has to have enough payload. We think you have to carry 4 passengers and a pilot to make the economics of this type of a service work. It's got to have the right range. It's got to be able to serve those trips on a daily basis that most people are taking and help us to capture some of that latent demand that's so exciting that's out there. We have to be able to fly fast enough so that we can actually save people time. So the aircraft has to go fast. Speed's really, really important here. And finally, as you just heard, or maybe you didn't hear, it's got to be quiet. Quietness is the magic unlock that allows us to make this new form of mobility something that everyone can use and want to be in their community, not hold it away. So to hear more about this machine, I'm incredibly excited to welcome Didier Papadopoulos, and let's get into the details.
All right. Thank you, Eric. That was really inspiring, amazing. I've actually never been close to both airplanes at the same time, so I'm pretty impressed already. So I've been in aviation for about somewhere between 20 and 25 years here, and I've had a lot of opportunities to celebrate a ton of things, but I have to say, like, nothing comes close to this. This is a once-in-a-lifetime opportunity, and I hope you all soak it in because this is really amazing. But there's 3 things I want to talk about here that we're celebrating primarily. And the first one of these is that this aircraft is going to deliver exactly on everything that this machine needs to do in order to support the vision that Eric and team were talking about earlier. That's an amazing achievement. Before I talk about what this aircraft really is, I want to take some time to thank everybody for the hard work. Like Joby was saying, this has been years in the making. There's been a lot of sweat and tear getting us to this day today. But I want to say a particular heartfelt thank you to the team who's been working particularly hard the last few months getting us to this. The aircraft looks awesome, it looks shiny, but it took a lot of days and nights and lots of sacrifices from many of you guys and also your families. So thank you all for that. And also, if I've been a pain, I'm really sorry. Really appreciate all the hard work here. All right, let's talk about the amazing things, the things that Eric talked about relating to the aircraft. So from a payload standpoint, he said 4 passengers, 1 pilot, check, with about 1,000 pounds of payload. We're going to be able to deliver on that with this aircraft. Woo! Eric also talked about a range, and it's really important to think about a range from many perspectives. We're going to be able to deliver on the necessary range for Eric and team to perform all of the missions that he mentioned. But it's really important to realize that we did that without sacrificing anything associated with safety, certification, or even the appropriate reserves that we need to do in order to support these missions. Not only that, what was really cool about what we did is we optimized the aircraft so we can be very effective throughout the day with all the cycles. What does that mean? That means we tuned the airplane to where you can land, unload passengers, load passengers, and be ready to go on with a fast charge turnaround. So we could be doing these things back to back throughout the day, getting the maximum utilization we can get from the aircraft. This is not a one-time deal. This airplane has to operate reliably throughout the day. Next, Eric talked about speed. We're going to be able to go as fast as 200 miles per hour. Remember the billions of hours he talked about that people waste in traffic and waiting on, cars and so on. Well, this is giving people time that's valuable to their life so they can use it for other things. So we're delivering on that. And last but not least, we're also delivering on what you heard or did not hear. If this clicker works. There we go. So the aircraft we're producing is going to be at least as quiet, if not better, than what you heard today. That is really impressive. With a maximum takeoff weight of 5,300 pounds, this aircraft, we believe, is the lightest and quietest eVTOL of its kind. It's an amazing achievement from everybody here. So big claps, please. I think I need the new battery. We have a few back here. I don't know if we can plug it. Sorry, thank you. All right, now think about all these performance numbers, but one thing we didn't talk about is the amazing customer experience. Big, large windows, spacious interior, and let's face it, who doesn't want to cruise the beach on an aircraft like this? I mean, this is going to be phenomenal. I'm just going to get on it so I can get the view. So amazing, amazing, amazing. All right, let's move on to the next point here. So I talked about 3 things we want to celebrate. The aircraft is amazing, but we should also talk about how this aircraft was built. That's equally important. Joanne talked about how we started this vision a long time ago. And one of the key things we did in 2014 is this subscale demonstrator. This tech demonstrator was sort of the proof in the pudding that we can do this. The technology is there, and we're going to make this happen. That was a huge achievement. The next biggest one is 2017 and 2019. Now we did a full-scale demonstrator. So this is the aircraft that you see here. It's for real, it's the real size, and we proved again that we can do it. A huge monumental lift is what comes today. We were able to build the real airplane on the production line. This means that everything, soup to nuts, was exactly how we're going to build multiple airplanes. So to give you an idea of sort of what that means, it means that all of the engineering drawings have been released to manufacturing so that they can build them under configuration control within the appropriate specs. It also means that from beginning to end, we have traceability for everything we did on the manufacturing line, from the smallest piece of equipment all the way to the largest system. It means we have repeatable procedures in place with the appropriate quality standards and tests to make sure that we're always delivering the same level of quality. And more importantly, it means hundreds of amazing Joby people who have been trained to do this over and over and over again, because we're not here to do just one airplane. And if you were to walk the manufacturing line, you would see now the second and the third coming right along. This is not a one-time deal. Very impressive achievement. And I'd love to show you guys some of the amazing work happening here in Marina, some of the work happening in San Carlos, and some of the other sites supporting us across the world. Everything from composite parts to electronics, to making parts, assembling parts, bringing all this aircraft together, done right here. It's just phenomenal. I've never seen anything like this. Woo! There we go. All right, so this first aircraft that we have produced and is sitting here, I'm also excited about because this will be the first aircraft that will be delivered to the DoD at the Air Force, at the Edwards Air Force Base. So that means this airplane will also be put into action. It will actually be operating with us and the DoD. It's really, really amazing that we're able to do that. And that's because we have confidence in the quality and the performance of the aircraft that we've built. What's also really important behind all this, think about it, step back. We've actually completed a full dry run of our manufacturing line. We've learned a lot of things, and we're feeding these into the second, third, and fourth airplane. That's obviously impressive. But remember, we're not here to build just tens of airplanes. Our plans, and we'll talk about these soon in the future, is to build a much bigger factory, what we call the Phase 1 Future Factory. All the learnings from this dry run helped us build confidence that we are on the right path with the designs we have and our plans to build hundreds of airplanes a year. So to me, that's worth amazing, and we really need to be thinking about it from that standpoint. This is all about scale. It's not just about one airplane. So congrats and kudos to the team for that. So one last point on the second bullet is when I say the team, I really want to reemphasize what Joby said. The team is not just the Joby team. It's the Joby team and our partners, but particularly also express deep gratitude to Toyota. If you walk around here any day, if you walk around San Carlos any day, if you walk around Santa Cruz any day, the Toyota team is literally integrated with us. There's no Toyota or Joby. It's like we're all here together. And the same thing happens in Japan. I got the opportunity to go and visit in March or April, and I was just amazed by the number of people working on this project, but also the investments that Toyota has put forth. So Toyota is helping us with supplying parts, Toyota is helping us with design optimizations on our components, and then also optimizing the manufacturing line. So again, thank you very much for all the help we're getting. All right, the third point I want to celebrate here is the Joby culture. By the Joby culture, I mean the Joby culture of engineering. And by engineering, I don't actually mean just engineers. I mean everybody here, day in, day out, is engineering, whether it be manufacturing, whether it be design, whether it be planning, supply chain, QA. Can I hear everybody here? Finance. There's almost this fanatical desire at Joby that just impressed me when I first started 2 years ago, where we just want to understand everything and understand how to push the limits to get really the maximum potential of everything we do here. And that's really unique. I have never seen anything like this, and I think it's something really important for us to keep. You combine that desire and that culture with the investments and ability to design, manufacture, test, and then come back and do this over and over in-house with every component that we have on this aircraft is just phenomenal. Being able to understand every piece of your airplane is so critical in being able to say, yes, we can hit these numbers. It's very hard to do if you don't understand all that. And that's really the magic that Joe Ben and team have established since day one. I want to show you a bit of video on some of the amazing testing investments we do here across the Joby sites, but also some of the other sites. It's really phenomenal, from pieces of electronics to major sub-assemblies, major assemblies like the wing. Some of the quality aspects that team's working on here is just phenomenal what we see on site. Now, I want to take a step back here and mention something about my background. Before joining Joby, I was at Garmin Aviation for about 16 years. And I really saw firsthand the value of true engineering, but also using that engineering to bring advancements to technology, was directly correlated into safer airplanes. It's all about safety here. You use technology to advance safety. And I think what's really cool about what the team is doing here at Joby is not just that we're doing technology for the sake of technology, but for two things. One is really creating this new era of aerospace. We're really creating something that doesn't exist. But I wholeheartedly believe that by doing that, we're also going to push the limits on safety and make aviation even safer than ever. And that's very critical that we keep in mind in every piece of equipment, everything we do here. Last but not least, this knowledge base that we have is not just for this airplane. It's not just for this initial type certification. What it's going to allow us to do is, as we learn of opportunities in the future in the market, because we have everything in-house, we're able to pivot and take advantage of the knowledge base to evolve the aircraft into more capable ones, more opportunities so we can serve more markets, like Eric was talking about earlier. And that's really the value and the secret sauce of what we're building here in reality. With that, I'm really excited to pass it on to John, because he's going to talk to you about all these amazing technologies that we've developed in-house. And with that, thank you so much, all.
Thank you, Didier. Gosh, I can't believe they gave an engineer a microphone. Pleased to be here this morning. I've been working on electric powertrains for more than 15 years. Designing high-performance electric motorcycles, which has now become the Harley-Davidson Livewire. Then at Tesla, I led the engineering of the battery systems as we commercialized the Model S to scale, and we introduced the home and grid-scale batteries. And then releasing the low-cost Model 3 battery system. And I've seen firsthand how vertically integrated design can change the world. At Tesla, we designed everything about that car from first principles. Rather than simply replacing an engine with a battery and electric motor, we're taking a similar approach at Joby. We've been able to leverage a lot of that learning from the automotive industry, where the technologies were developed over many years. But our aircraft and our mission have unique requirements that require us to fundamentally rethink how we design and build aircraft, and to develop our own solutions, as Didier mentioned, that fully realize the potential of an electric powertrain. Electric propulsion allows us to design a small aircraft with unprecedented levels of reliability and redundancy, with no single points of failure. Each of the 6 motors on the plane are dual wound, which means they're essentially 2 motors, and they're driven by separate inverters that are powered by different batteries. On the plane, we have 4 electrically isolated, fully redundant battery packs. We can continue to fly safely and land with the loss of any part of the motor, the inverter, and even an entire propulsion station or a battery pack. And not only that, the entire powertrain of our aircraft is best in class across every important metric, from performance to weight and reliability. The Joby motors outperform anything on the market for our use case. They each deliver 236 kilowatts of peak power at a weight of just 28 kilograms for the dual wound motor and inverter. With 6 propulsion units on the aircraft, that's nearly twice the power of the Model S Plaid, the most powerful Tesla, and the whole aircraft weighs less than that car. That was a lot of work. Our motors are highly integrated packages. They contain not just the dual wound motor and inverter I talked about, but also the coolant pump, the radiator, fan, the hub, propeller, and the pitch actuation mechanism. Taking an integrated approach to design allows us to add all of this functionality in a lightweight, compact package. It's pretty awesome to be able to pick up 236 kilowatts. But it's not just the power and the weight that makes our motors special. It's the way in which that power is delivered. There's a lot of brilliant engineering behind making that plane as quiet as we just heard. One key piece of that is being able to spin the propellers as slowly as possible while still generating the amount of thrust we need. To accomplish that, we designed motors that are incredibly torque dense, offering as much torque as a heavy-duty F-350, which I definitely cannot pick up. The obvious way to achieve that kind of torque is by using a gearbox. And a gearbox allows you to multiply the torque of the base motor elements, the copper, the steel, the magnets, and therefore use less of them. And we did that at first. This is a photo from 2017, 6 years ago, when we designed, built, and flew our first full-scale aircraft using gearbox motors. But there's a downside to using a gearbox. Our design had 7 intermeshing gears, each with a multitude of rolling element bearings and dozens of gear teeth that are constantly running through fatigue cycles. Every one of those parts has to be tracked, inspected, lubricated, and replaced throughout the lifetime of the motor. They also create excess vibration and noise that impacts the rest of the vehicle. We decided that wasn't good enough for us, and we took a more challenging approach. We believe that'll have a much greater payoff in the long run to meet our performance requirements and our acoustic requirements with no gears. We designed and patented the Joby direct drive motor architecture. Our motors deliver all of the power and torque they need with only one moving part, a single bearing. An electric motor this simple can last the life of the aircraft, enabling highest utilization and reliability with less maintenance. Now, the story is similar when it comes to the batteries. We didn't want to compromise. We wanted to find the best possible solution, even if it takes more work on our part. Our mission has a lot of different requirements to balance. We need high specific power to get the aircraft off the ground. We need high specific energy to complete long trips. And Eric talked about rapid charging. We, of course, need long cycle life to make the system last as long as possible, thousands of flight cycles at least. Our challenge was to find a widely available cell that has the best balance of every one of these characteristics. For more than 6 years, we've tested hundreds of cells in our laboratory. We understand really well how they perform on every one of these metrics. Now, the obvious first choice would be a cylindrical cell. Cylindrical cells are widely used in automotive and consumer products, both because they're a standardized format, but also because the techniques for packaging them to battery packs are well understood. But even the best cylindrical cells we can find present two major problems. First, they don't offer the level of specific energy we needed for maximum performance. They're heavy. Second, in our testing, we find their capacity deteriorates after just a few thousand trips. In operation, that translates to more frequent battery pack replacements, and of course, worse economics. So we looked at all the available options, expanding beyond cylindrical cells to include prismatic and pouch cells, and we found a line of pouch cells that delivered on every metric that matters to us. The cells in the production plane behind me weigh in at 288 watt-hours per kilogram at the cell level, and we've demonstrated in our lab more than 10,000 representative flight cycles. They come directly out of the automotive supply chain, which means they're widely available and well understood. And we leverage significant prior investment by the automotive industry into quality and reliability at scale. Beyond selecting the right cell, the innovation by the Joby team is turning a group of cells into a robust, reliable battery pack. And since we selected a pouch cell, this took a lot of engineering work. These battery packs are tightly integrated into the wing, and they're designed to operate in all flight conditions that the aircraft will experience. Of course, variations in altitude, vibrations, temperature swings, any extreme conditions. We designed and implemented the battery management electronics, the supervisory software algorithms, and all the lightweight and durable structural cases. The result is a specific energy of 235 watt-hours per kilogram at the pack level. That's worth a cheer. We're achieving better energy density, better specific energy at the pack level than a lot of the cells we test in our lab at the cell level. That's an incredible accomplishment by the team. And throughout the design process, we've worked closely with the FAA to confirm that our battery packs meet the stringent safety requirements that they require and that we want. We've completed preliminary tests that cover all key safety requirements, and we've submitted our certification plans to the FAA. We're very confident we have a clear path to certify these battery systems. What's really going to be important about the batteries once we're in service, though, is how quickly we can recharge them in flight, in between flights, of course. We've developed a charging solution that allows us to rapidly charge and turn around the aircraft in between flights, which maximizes the life of the batteries as well. Eric mentioned how most of the trips people make in cities like New York and LA are really short journeys. For 95% of all the trips made in today's target markets, we're able to recharge and turn around the aircraft in less time than it takes to deplane and load new passengers. That means we can turn around the aircraft for continuous service without ever waiting for charging, which is how we make the most out of every aircraft in service. We're really pleased with the performance of our batteries, but we're also always innovating and looking to take advantage of new technology. I've been following the steady and consistent progress in lithium-ion batteries for more than 20 years. And at Joby, we've been closely following the more recent developments in the industry as companies begin to prove the viability of cells with much higher specific energy. As cells like these are proven to be safe, as they're proven to be long-lasting and widely available, we'll be able to upgrade our aircraft. We'll swap out the old batteries with new ones to offer longer trips to more destinations. Together as a team, we've designed, built, and tested an amazing aircraft. It's amazing to be up here with it. I believe we'll be changing aviation forever, electrifying aviation and enabling emissions-free flight. Now, I got the chance to show some flashy slides and talk about some intricate details, but really, this is years of small battles, hard won by every member of the Joby team. From the cooks that kept us fed, thank you, and the janitors who swept our floor, to the many skilled hands whose fingerprints are all over this aircraft, and they're going to be on every airplane after it. I'd like to thank you all for your hard work and the dedication in bringing innovation to reality. Thank you. Joe Ben.
So it's been an incredible, I just want to tell a little story about John. John and I met John at a robotics competition at Stanford, and so I was there recruiting. And John and J.B. Straubel, who was the founder of, or co-founder of Tesla, were on a robotics team together, and they had just won. They just like absolutely crushed it out of the park. And I went up to him and said, hey, I want to recruit you guys. And JB was like, I got to finish my electric car. And but I was able to recruit John. And then, John and I ended up founding our first company together in 1999. And it has been incredible to work with John over the years. After we sold our first company, JB called me and said, hey, do you have somebody to run the battery team? And I said, what about John? And he's like, that's an amazing idea. So it's been a wonderful journey. I just love to give a shout out to Eric, to Didier, to John, to each and every one of the engineers. We have built such a spectacular engineering culture as John and Didier talked about. And so just thank you to each and every one of you. Please join me in thanking the team. Woo! So this last Sunday, when the team was working to put the finishing touches on this beautiful aircraft, we had the pleasure of welcoming a special guest. California Governor Gavin Newsom came and, thank you. California and the governor have done so much to lead the world in this transition of sustainable aviation, and now California is leading the world in this transition to sustainable aviation. And so it was just spectacular to have the governor here and to welcome him, and he recorded a few words for you guys. And with that, over to you, Governor.
Well, hey everybody, it's Governor Gavin Newsom, and I really wish I could be there with you all today. But as you can see, I got a sneak peek here just a few days before this celebration, and we are here to celebrate. We're here to celebrate passion, entrepreneurialism, innovation. We're here to celebrate, yes, technology. We're here to celebrate the future, and we're here to celebrate a great state. What we love to say about California, the future happens here first. And this is a demonstrable proof point. This remarkable company that's going to change the way, well, we live, the way we do business, the way we imagine things, the way we move things. And so I'm incredibly inspired. I'm incredibly passionate about the extraordinary work that's been done down here. I want to thank all the partners that are here, particularly all of those that are on the front lines, the folks working hard every single day that made this vision a reality. And so I'm here on behalf of a grateful state, 40 million strong, the world's fourth largest economy, eat your heart out Germany, to say how much we respect and appreciate and admire this extraordinary company.
Thank you so much, Governor, and thank you to everybody from our local government, Mayor Delgado, and everybody from our state governments, city officials, people from the city of San Jose, County of Santa Cruz, County of Monterey, state legislators, Senator Caballero, Senator Laird, Representative Rivas, Representative Adis, California Energy Commission, Caltrans, and representatives from states and agencies across the country. We are so, so grateful for you being here. Yesterday, we had 80 officials from the DOT, the DOE, NASA, the FAA that came down, and they were able to see what we've been working on. The amount of momentum and engagement has never been greater. We have folks from the JCAB in Japan, from the CAA, from the FAA. The regulators around the world are leaning in. We had incredible meetings at the FAA EASA Safety Conference in Cologne 2 weeks ago. We have got so much momentum and so much desire to drive sustainable aviation, and it's really, really an incredible time. Woo! I'd like to give a special shout out to Mark and Lynn Stoll, Alex Stoll's parents who are in the audience with us today. Alex was the first Joby employee and formed not just the technical heart of our company, but also the emotional heart in so many ways. He had incredible vitality and zest for life. He cared incredibly deeply about our mission and about bringing vertical takeoff and landing aircraft to the world. And he passed away this last spring, and he will be missed very, very dearly. It means the world to me that Mark and Lynn are here today. So thank you very much. So with that, I would love to invite a few of the folks from the Joby team who have just given so much over the past weeks and months to make this aircraft come true. Santiago, if you can come up. CJ, if you can come up. Eric, Lassen, Chino, Justin, Omid, Joe, Eric, Sasha, Rob, Nico, Rishing, Mitch, and Mark. Thank you guys so much. It is just an absolutely incredible. Woo! Thank you. Didier. So many amazing Joby team members, each and every one of you. I would love to give a special shout out to the testing team. You guys have been absolutely crushing it, and we are going to be so dependent upon you over the days and weeks and months ahead. And a shout out to the recruiting team. Joby is growing, Joby is hiring, and so each and every one of you can be recruiters for us too. It is vital that we continue to grow, that we have the resources and the team members we need to take this aircraft through the certification journey. I'm so grateful. Thank you to each and every one of these amazing people behind me. I live every day to get to see all of you and to get to work with all of you. Very, very grateful.